Okay, so now let's go through this one real quick. So this one is for the word problem. A lot of people are still struggling with the current, the speed of the bow problem. So let's take a look at that. It's on the back of the page of the chapter 6 study packet. Again, rational equation and expressions. So we're going to have a test like that tomorrow. So for number 3, it's showing that the speed of the bow in still water is 5 miles per hour. If the bow travels 3 miles downstream in the same amounts of time it takes to travel 1.5 miles upstream, so what is the speed of the current? So one thing that you need to do is to highlight a key number, and also you want to set up the table or the chart. Okay, so we do have two different directions, upstream and downstream. So for the upstream one, so we do know that the distance it travels, so the speed of the boat is 5 miles per hour. Okay, so the speed of the boat, in still water is 5 miles per hour. Okay, mph, and also this one, mph. And if the boat travels 3 miles downstream in the same amounts of time it takes to travel 1.5 miles upstream. Okay, so distance 1.5 miles. And the other one travels for the downstream 3 miles. So what's the speed of the current? So the speed of the current, we don't know. So for upstream, the speed of the current, it's always against, so minus x. Downstream is travel with the current, so it's plus x. And one thing that we know is that they use the exact same time. So one is going upstream, downstream. It's the same amount of time. So the way to set up this, we do know that distance divided by the speed, it's always the time. So that means it's going to be 1.5 divided by 5 minus x. So that equals 3 over 5 plus x. Well, because that they both use the exact same time for going upstream and downstream. But definitely going upstream, it takes shorter distance because that takes more time, because that's against the current. Downstream is going with the current, so it's only 3 miles. And now what we can do here, so cross multiply. Cross multiply. So we got 3 times quantity of 5 minus x. So that equals 1.5 times the quantity of 5 plus x. And then distribute, so we got 15 minus 3x. And then 1.5 times 5, which is 7.5. And then plus 1.5x. Subtract 7.5, so we do have 7.5 equals 1.5x plus 3x, which is 4.5x. And then divided by 4.5. And then solve for x. So we do have 75 over 45, which is, we try to reduce it, so we can divide it by 5, top and the bottom, so we got 9 here. Divided by 5 on the top, so we do have 15. And then reduce that again, so we do have 3 over, divided by 3 top and bottom, so we do have 5 over 3. So it's about 1 and 2/3 hours. Well, it's not time, it's actually the speed, so it's mph, miles per hour, excuse me. Okay, so that's for number 3. And for number 4 is pretty similar. Okay, and also we can deal with that. Again, it's the same kind of structure. It's about the speed of the current, the speed of the boat, the distance, the time. So once we set up the chart, so we can generate the equation and then solve for the variable. Again, the key factor is that whatever the question is asking for, so we always want to use that as the variable. Okay, so for that one, the current of the river is 2 miles per hour. So 2 miles per hour for upstream is minus 2. And then for downstream, it's going with the current, so it's 2 mph. And a boat travels to a point 8 miles upstream and back again in 3 hours. So 8 miles is the same distance back and forth. And then, so the total time it takes is 3 hours. And we need to find out the speed of the boat in the current, in the still water. Okay, so the speed of the boat, we don't know what that is. Again, so distance divided by speed, it's always the time. So the thing is that we need to find out the total time. So eventually it's going to be 3 hours. We're going upstream and downstream. So starting with that upstream, so we got 8 divided by x minus 2. And then plus, because that is the total time it takes. So this one is time 1 for going upstream. And then we need to find out time 2 for going downstream. So 8, also the same distance, divided by x plus 2. Again, it's a rational equation. So the way to solve for this, so make sure that we put in 3 over 1. If there's no denominator, that means the denominator is always 1. So now the next step, we want to find out the least common denominator. The reason why we find the least common denominator, because this one, they're not factorable. Normally we try to factor it first to find out things that they share in common, but since nothing they have in common, so we just want to find the least common denominator. So we just want to multiply them all together. X minus 2, x plus 2. You're right, this one is the pattern of difference of 2 squares. You may notice that. X minus 2, x plus 2. So the way to convert that to the least common denominator, we need to find out the missing element. So this one, compare and contrast. So we do have x plus 2, which is missing there. So we just multiply by x plus 2, top and the bottom. And then over here, obviously x minus 2 is missing, so we multiply by x minus 2. And then this one right here, the constant, so we multiply pretty much everything. X minus 2 and x plus 2. Or the other way around, x plus 2, x minus 2. Eventually, we're going to FOIL them. So distribute on the left-hand side, so we do have x times 8, which is ax. 2 times 8, 16. Over here, we got ax and also minus 16. And then the right-hand side, once you distribute, well, this part right here, just like difference of 2 squared. So it's x squared minus 4. So technically, it's just like 3 times the quantity of x squared minus 4. So we got 3x squared minus 12. So 16, negative 16 got canceled, so we do have 16x. And then the right-hand side, just bring it down. So 3x squared minus 12. And what happened with the denominator? The denominator, they all consider the same, so that means we can cross them out. And now, the only thing that's remain is the least, well, the quadratic equation with the least power, 2. So, well, with the least power, zeros, the highest power is 2. So we want to bring everything together. So you want to solve for the quadratic equation. So we got 3x squared minus 16x minus 12. So that equals 0. And one thing you want to check first is that the greatest common factor. Well, there's no greatest common factor, so that means we just want to factor it with the smiley face. Okay, so using the smiley face, so 3x squared minus 16x minus 12. So 3x squared, we got 3x, 1x, and then negative 12. So let's think about that, the way to put this together. We can use negative 6 and positive 2. Okay, so negative 6 right here on the right-hand side, and then positive 2. So 2x, and then negative 18x. So that will give you negative 16x. So now, let's put this all together. So once you put this all together, so we do have 3x plus 2 times the quantity of 1x minus 6. So set that equal to 0, so we do have x equals 6, and then x equals negative 2/3. Since we're talking about the speed of the boat, so the speed is always positive number, it cannot be negative. So the negative, it's not the valid solution. So the only solution we have is 6. So the speed of the boat, which is 6 miles per hour, 6 mph. And thank you for watching that video today.